Hello everyone and welcome back to another Algo Skills LeetCode tutorial video. In this video we're going to be covering LeetCode 2707 extra characters in a string. So we're going to be breaking down the question, then we're going to be moving over to the whiteboard where I'll kind of explain how we're going to solve the problem, and then we're going to of course be writing some code. So if you are serious about LeetCode and you're serious about data structures and algorithms, you want to get better, you want to kind of land that dream job, then I would highly recommend checking out our course Algo Skills. I'm an ex-Amazon software engineer. I've done it before. The course shows you exactly how to get into, that dream job, that FANG company. So if you're interested in that, I'd highly recommend checking it out. Top link in the description. But let's get into the video. So to start off with, let's just read the question. You were given a 0 index string S and a dictionary of words dictionary. Okay. You have to break S into one or more non-overlapping substrings. So just break it up into kind of different chunks such that each substring is present in dictionary. Okay? There may be some extra characters in S which are not present in any form of the substrings. Return the minimum number of extra characters left over if you break up S optimally. So we have these extra characters and we just want to break S up into as many, so it matches with as many words in dictionary so that there is the minimum number of extra characters left over. So let's take a look at the example. We have LeetCode as the string, and then we have the dictionary with LeetCode and LeetCode. Okay, so you can kind of visually see what's going to be done here, kind of just intuitively. So we're going to match Leet here, and then we're going to match code here because those are both in the dictionary, and that's going to leave this S character right in the middle here, which is why we output 1. And then take a look at the second example, say hello world, dictionary of hello and dictionary of world. So obviously hello matches right here, and then world matches directly after it. So all that's going to be left over is this say, which is why it's an output of 3. So that's pretty straightforward. Let's take a look at this example in a bit more depth on the whiteboard. So I'm going to kind of show you how we're going to be solving this problem in a programmatic way, which will directly map over to our code. So we're going to be approaching it in a top-down or memoization dynamic programming approach. This is most easily done through dynamic programming, and I have tested both the top-down and the bottom-up approaches, and top-down was more performant. So in my opinion, it's easier to understand, it's kind of easier to grasp, and also easier to just come up with them in an interview. So we're going to be doing the top-down approach, but we have the exact same examples. So LeetCode, and then, oopsie daisy, I have missed, this should be, let me double check, yes, this should be Leet's code. Okay, that would have caused some confusion if we went through. So we have Leet's code as our example. And then because we're doing top down, so we're going to have a cache. This is our cache here, which we're going to fill out. So to kind of explain it before we jump in, what we're going to be doing is we're going to kind of just be moving through the string and trying to find kind of bits that match with the dictionary, and then, searching the remainder of the string and trying to just kind of keep finding those bits that match with the dictionary and just kind of keep going through it. And then what our cache is going to be holding is the length of the string from the end and the amount of remaining characters. So for example, as an obvious example here, once we get down to here, code, so the last 4 characters, this directly matches. So there's 0 remaining characters. So what we're going to be doing is we're going to be matching 4 with 0. So that's what our cache is going to be doing. And then just for another example, if say we're at S code, this is going to have 1 remaining character here. So S, and then 4 are all going to match. So there's none. So it's just going to be 5, which is the length of this, and then 1, because that's how many remaining characters. So that's kind of how we're going to be using the cache in this example. So let's get into kind of going over it and kind of thinking about how the program is going to be doing it. So we're going to be starting off obviously from the very start, and then what we need to do is we need to see, hey, does this match with any of the things in our dictionary? Can we do any matches from this starting position, from the position we're at? And as you can see, Leet that's a match right there. We can match Leet. So we have that as a, oopsie daisy, we have that as a direct match there. And so what we can kind of do is that now that we've got this, we know that all this entire bit here is matched. So the next thing we need to do is, so we need to search this remaining bit, see if we can find any matches there. So we're at S code now. We've skipped all of this. We're going to be coming back to it later, but we have skipped it. So now we're at S code, okay? And so we then take another look. Okay, S code, are there any matches here? No, doesn't match with Leet, doesn't match with code, doesn't match with LeetCode. Okay, so no matches there. Let's go to the next character. Code. Okay. Does code match with anything here? No with Leet. Okay, it's a perfect match with code. So this bit here is a match. So again, same logic. Let's skip over all of this and let's go after it. Okay, now we're at the end of the string. There's nothing to search. So we know we've searched everything that we can. So let's go back here. And now we know that this must be the minimum. We found the minimum number of extra characters left over here because there's a direct match here. So there's 0 here. So now let's update our cache. So let's update this 4. When you have a length of 4, this should be a length of 4 should map to 0, right? Cool. And so now let's go back again. So now we're here. So we have a length of 5. And we found that this maps to 1. Okay. And then let's go back to here. But we still have more searching to do from this point. So we're going to we've searched from this starting character. Like, we're not going to update the cache now to for 9 for this entire thing as 1, which is what we found so far, because there could still be other combinations that are better. So what we're going to do is we're going to just start at the next character. Okay, so we go to E. Anything here that matches with this, so eats code or eats or eat. Obviously no. Let's go to the next character. Now we have another E. None of these even start with E, so we know that's false. Okay, T. None of these start with T, so again, false. Now we're here. Now we're at S code. But we don't actually need to search here, because what we do is we check the cache and we go, oh, we know that the minimum number of extra characters at 5 is equal to 1. So we know that this is equal to 1. So now we don't need to search anything else, because we already know like kind of everything over here. We've done it before. There's no point doing all that work again, because we've already done it. So now what we can do is we can go back here, and this is going to be 7. So 1, 2, 3, 4, 5, 6. Oh, sorry, 6, and that's going to map to 2, because it's just going to be 1 bigger because we don't have any matches, and that pattern's going to kind of keep following. So 7, 8, 7. Oopsie daisy. 7 is going to be 3. 8 is going to be 4. And then finally, now once we're back at the start, we've done all the searches that we can, and we know that this is going to map to 1 spare character, which was that original solution we found. So we're going to be kind of keeping track of that. So we know, after doing all the searching, that the best solution is Leet and code with this as our extra character. So that's how we're going to be doing it. I hope that made sense. Now let's get into actually writing the code. So we need to have our cache. So I'm just going to initialize our cache there. And then we need our depth first search function. So I'm going to be creating it. And then this is going to be passing in whatever text we're searching. So at the start it's just going to be S, but then it's going to keep getting smaller and smaller. Let's skip that for a second, and then let's just go down the bottom. We're just going to be returning DFS with our full string. So now let's write our depth first search code. So first of all, if we get to the point where there's no text left, we're just going to return 0 because we don't want to kind of keep dealing with it. We've already, there's nothing left to search. The next thing to do is what I was talking about in the example, is we don't want to keep searching stuff if the answer's in our cache. So if the length of the text has already been added to our cache, meaning we've already done the search, then we can just return the cache. We can just return whatever value is in our cache. Okay, so now we've got kind of those two little base cases out. Now it's time to initialize the minimum value, which is what we're going to be, how we're going to be keeping track of whatever the minimum number of extra characters is as we go. So that's going to start off being the length of the text, because that's going to be the worst case scenario is that none of the characters match. So we just will return whatever the length of the text is. All of them are extra characters. Cool. So now let's go through each of the words in the dictionary. So for a word in dictionary, first of all, ideal scenario is if it's an exact match. So if the text is equal to the word, that means that the minimum is going to equal to 0. You know, we can probably just write this even more, possibly more clearer. Actually, no, I'll keep writing it like this just because it's how everything else is going to be formatted. So we're going to set the minimum equal to 0. Then let's update the cache. So the cache of length text is equal to minimum, which is of course 0. And now let's return the minimum, because there's no better solution than this. This is the absolute best case scenario. So there's no point to keep searching. It's just a waste of resources and kind of a waste of the cache as well, a waste of time and space. So if it's not an exact match, the other scenario is that it's a partial match. So if from the start of the text to whatever say the word is 4 characters, let's get the first 4 characters of text, and if it's equal to word, then let's keep searching the remainder of that string after the length of the word. So we'll do another depth first search. So that's going to be text of length word onwards, and then minimum, we'll just update this to whatever's smaller, so the current minimum or the result. Cool. So once we've searched all the words, then the next thing we want to do is we want to search from the next character over. So minimum equals to the minimum or 1 plus DFS of text 1 onwards. So just to clarify this part, so this is obviously searching from the remainder of the string excluding the first character. So we've just moved 1 character across, and the reason we're adding 1 to this is because there's 1 spare character, which is the current character which we're skipping over. Finally, let's update the cache. So cache length text equals minimum, and then let's return whatever we found to be the minimum. So let's see if this code is working. So it looks like it is working. I'll submit it. And as you can see, quite performant, and that is basically the solution that that we've created. So I hope this video was helpful. If you enjoyed it and you found it useful, please like and subscribe. Thank you guys so much for watching. Have a good one.